Hello everyone, this is video 7.2. We're going to be looking at solving ratios and proportions by reasoning and multiplication. So we'll be looking at some sort of fairly basic, fairly intuitive problems with ratio and proportions, but I'm going to take a slightly different approach to this video, and we're just going to look at two examples, and I'm going to solve them a bunch of different ways to give you a sense of some techniques, some ideas. If you've solved these problems pretty much one way, just multiplicatively, which I think is how a lot of people would solve them. If you only have that one approach, then that's pretty limited. So we want to be able to show students a number of different ways to solve and think about and conceptualize these problems. So that's what we're going to be doing today. So let's get started. So this first problem, I get paid $10 to mow a yard. How many yards do I need to mow before I have $60? Now, everyone watching this video knows the answer to this question. So the mathematics of how to solve this is not really as much at issue as much as the way of thinking about and structuring this for students who aren't going to be able to solve this as quickly and as intuitively as you might. So let's have a look. So this first approach, this is called the additive approach, and we're going to make a ratio table. So we got the number of yards that we've mowed, and then we have our money. And so for 1 yard, I know I get paid $10. Now the additive approach is exactly that. I'm just going to add, for my second yard, I get $20. My third yard, I get $30. And this is my money total. I'm not going to get $30 just for the third yard. Let's be clear about that. Fourth yard, I got $40 total. 5 yards, I got $50 total. 6 yards, I got $60 total. Ta-da, there's my answer. So you can see already sort of the pros and cons of this approach. The pro being there's not a whole lot of high-powered mathematics at work in this solution. We're adding. That's it. I need to keep my ratio. So 1 to 60. I need to keep that 1 yard to 1 to 10. The 1 yard to $10. I have to keep that. But other than that, all I need is just addition. That's it. So the pro is that this is a very concrete way of working with ratio. It's a good introductory method for talking about ratio. The con, as you can imagine, if I wanted to figure out how many yards would I have to mow to have $1,000, I'm not going to want to sit here and write out 100 columns of this table. So it is limited to relatively small numbers, but it does allow us to see that students understand the importance and necessity of keeping a ratio constant. That second yard isn't going to be worth $15, the third yard won't be worth $8. That ratio, 1 yard to $10, 1 yard to $10, this additive piece here, and that constancy of the ratio, it does allow us to assess whether or not students understand that piece of this. So this is the first one, the additive approach. Now, we also have this thing called a doubling approach. And so this would be helpful in a case if I had, like we talked about, 1,000 yards or $1,000. So how many yards would I need to get to that? And so in the doubling approach, I'm going to do pretty much the same thing. So here's my yards, and then here's my money total. And so I'm going to take 1 yard, and that's $10. And now, rather than just add, I'm going to double this. And so by doubling, I've got 2 yards, means I have $20 total. If I double this again, then I have 4 yards, gives me $40 total. And now I can look at this and I can do this additively. I want to get to $60. So I've got $40 here and $20 here. So I know I should be able to add these together. So 20 and 40 makes 60, and likewise 2 plus 4 makes 6. Now, the pro for this is that it allows us to get to these larger numbers a lot quicker. Now, we only really saved ourselves 2 columns here. We didn't do the 3, we didn't do the 5. Well, 6 is a pretty small number, right? So, I mean, if you think about that in terms of like the sheer number of cases, we haven't reduced that much. But on a percentage basis, we've eliminated 33 1/3% of the work. That's pretty significant. So if we don't want to write out the addition part all the way out to wherever it is that we need to go, this allows us to sort of fast forward a little bit and get further down the line. So this is this doubling approach, which also uses a little bit of that additive approach if we don't double right onto it. I mean, if we were looking for how many yards to mow for at $80, then we would double that 4 again, and we'd be there, and there wouldn't be any additive piece to it at all, or no explicitly additive piece, I should probably say. So this is our doubling approach. Let's look at a different problem. So we have a dish has 3 cups of chicken and 2 cups of sauce. How much sauce do I need for 12 cups of chicken? And this is a little bit different of a problem because that yard to money problem was already a unit rate. It was 1 yard to $10. So it wasn't the 2 yards to $15 where we're not giving it as a single yard. We're not giving it as a unit rate. So this is a little bit more complicated. Also, this problem is a little bit more complex because we've got the chicken, we've got the sauce, and we've got the dish, which is the combination of the chicken and the sauce. And again, we're assuming there's nothing else going into this. There's no, breadcrumbs or cheese or whatever. There's no additional thing. So this dish is only made up of chicken and sauce. That's it. So how much sauce do I need for 12 cups of chicken? So one way to think about this would be to put this as a ratio of cups of chicken to cups of sauce. And so I know that I am in a ratio of 3 to 2. So I've defined my ratio of chicken to sauce. I'm in a 3 to 2 ratio. If you want to write this as 3 cups to 2 cups, you can. I mean, the units are sort of specified in the way we define the ratio. But if you want to put 3 cups to 2 cups, that doesn't hurt anything. So I want to know what I need for 12 cups of chicken, specifically what the problem is asking. So in this case, it works out pretty well because 3 divides into 12 evenly, so I can tell that I just need to multiply this by 4. And so, sort of building on our doubling approach, at the doubling approach, we just multiply by 2 because it's an easy thing to do. And even students who may not understand fully about a, multiplication or doubling can understand the idea of adding something to itself. So in a very intuitive, implicit way, understand what multiplication and doubling is. Here, we're taking a little bit more insightful approach. I just want to multiply one time, and I want to multiply by the number that's going to get me to where I need to be. So what do I need to multiply 3 by to get to the 12? And in this case, it's 4. And so if I multiply this side, the chicken, by 4, then I have to keep this in a constant ratio. The sauce also needs to be multiplied by 4, and so I have 8 cups of sauce. So I'm trying to show you sort of like this natural progression from additive to doubling to multiplication. So this is a sort of a next step to that. Doubling was multiplication by a number that you're just sort of told to multiply by. Here we understand why we're using the 4 and not a 2 or anything else. So this next strategy is called the part to whole table or a part to whole model, diagram, whatever you want to think about it as. And so I'm going to kind of bend this problem a little bit so I can show you this method. We could do it as a part to part model as well. I think by the end of this you'll see how we could use it in that way as well. So I'm going to kind of take a very scenic route to solving this problem just so you can kind of see this model at work. So we know that if we have 3 cups of chicken and 2 cups of sauce, then we're going to have 5 cups of dish. So we've got 5 cups of the dish. So I can draw a little table, or draw a little diagram rather. 1, 2, 3. And so here's my chicken, and here's my dish. So I know this is in 3 to 2, so I can see here's my 1, 2, 3 for the chicken, here's my 1, 2, 3, 4, 5 for the dish. And now I want 12 cups of chicken. And so to keep this constant, I'm going to make this 4, 4, and 4. And so that gives me a total of 12 cups of chicken. But if these are all 4, then these also need to be 4. And now my dish, I've got 20 cups of the dish. But of that, 12 is chicken, and so 8 cups must be the sauce. Now, the reason why I wanted to show this model was because I can also look at this. If I break this up this way, I can think of this as my chicken, and then I can use this as my sauce. So this model allows us to see that whole as both one piece, just the whole, or as the sum of these two parts. So those 5 boxes make up the dish, of which 3 boxes are the chicken, 2 boxes are the sauce. So this is really not a whole lot different than the multiplicative model that we looked at before, um, because we still need to understand that it takes 4 to do this. But using these boxes up top, it allows us to do that multiplicative piece without ever really saying anything about multiplication. I need these 3 boxes to add up to 12 and to be of equal size, so we can get that. And essentially, that's the division or multiplication problem. Again, without saying it. And then once we know that each of these boxes are 4, that's our multiplier. So now we know the size of the dish, and the size of the chicken, and the size of the sauce. So it's just a means of allowing us to work with something where parts and wholes are both sort of used within the problem. It's a nice concrete way of structuring and organizing the pieces that are in the problem as well. So this next method is called the multiple batch method, and it's not really an awful lot different than what we've seen in terms of the multiplication, but the book draws it in a slightly different way. Um, so we've got our chicken and we've got our sauce. So we're doing it kind of as a like a double number line here. So we know we've got 3 to 2, and then we can do this either additively like this, and so 4, 6, 8. We could do this multiplicatively, multiplying by 4. It's a little sloppy there. So we can do it this way, but the point is that when we're working with this batch method, that we're kind of keeping these things together and working with them, these ratios at the same time using this double number line. Uh, it's like I said, not a whole lot different from what we've seen. So the distinction between this is mostly sort of the presentation. It's all the same idea of ratio and proportion. So yeah, there's not a whole lot to say this. But the next one, this is the unit rate batch, and this is a little bit different. And so this is going to be especially helpful for cases where maybe the numbers don't divide evenly. So if I wanted to do, say, 3 cups of chicken and 2 cups of sauce, then how much sauce do I need for 10 cups of chicken? So we can change the problem around just a little bit here. And so what we do in this problem is we've got our 3 cups of chicken, to 2 cups of sauce. And so now we're going to divide by 3. And so that gets us to this 1 cup of chicken. And so now we know that's going to be to 2/3 cups of sauce. And so we're kind of come full circle here. We're back to the sort of problem that we talked about at the beginning with the 1 yard and the $10. So we've got a unit rate now. Remember, when you see the word unit, we know we're talking about one of something. So we're talking about 1 chicken. And we know that we are trying to multiply this to get to 10 cups of chicken. So since we're trying to get to the 10 cups of chicken, we know that's the unit that we need. If this problem were 10 cups of sauce, well, we could just do the 5. We wouldn't need the unit rate. But if we were going to say do 5 cups of sauce, then we want to do the unit rate on the sauce. We would divide by 2. We'd have 3/2 a cup of chicken to 1 cup of sauce, and then do the multiplication from there. So where we're trying to head toward, what we're looking for in terms of the piece of information that we're given. That'll help determine which part we need the unit rate of. So now that we have the 1 cup of chicken, we know we're multiplying by 10 to get to the 10 cups of chicken. So then this would be to 20/3 cup of sauce. So just shy of 7 cups of sauce. Now, some of you might be thinking, can't we just use the multiplication method, do this all at one time, and multiply this by 10/3? Absolutely, we could. But not a whole lot of students are going to be able to kind of like think that far ahead in that multiplicative of a way. Some will, a lot won't. And so getting to this unit rate by multiplying and dividing by whole numbers, by integers, is typically a much easier approach. Now, at the end of this, if students recognize that this divided by 3 and this multiplied by 10, that could be combined into one step and just do multiply by 10/3, great, all the better for it. But as an introduction to this, breaking this into steps, having an idea of where we're trying to get to, that we're trying to get to this unit rate of chicken, which is a strange phrase, that's going to be our target and give students a lot more reasonable goal to work toward. So for your checkpoint, we've got a dish that has 3 cups of chicken and 2 cups of sauce. How much sauce do I need for 12 cups of the dish? Not 12 cups of the chicken. So we've changed the problem around a little bit. So whichever approach you want to use, any of the 5 or 6 that we mentioned in this video. Again, think about the solution, but also think about how you would explain that solution. As always, if you have any questions, please, by all means, bring them to me, and we'll get them answered. All right, thank you.